Um, we want to look at quadratic equations. This is purely for high school students. So normally, if we want to solve quadratic equations, we can use factorization method, use completing the square, use graphical method. Uh, any of this method you use, you can have your answer. So, but what I want to look at is quite different, even though it's similar to those methods that you might know. We know the nature of a quadratic equation is like ax squared plus bx plus c equals 0, where a should not be equals to 0. The highest power of a quadratic equation should be 2, right? So the coefficient of x squared here, a, we said the condition should be not 0. If it's not 0, then this is okay to be a quadratic equation. So it can be any number other than 0. For instance, a can be 1, a can be 2, etc., as the case may be. So if that is the case, let's say this time around a is 1. If a is 1, a is going to be x squared plus bx plus c equals 0, because if this is 1, 1 times x squared gives you x squared, then b by a, or let's say b divided by 1 is the same as b, and c by 1 is the same as c. So we end up having this expression. So that's the case. That is the case. Now let's just replace some of these variables. Let's say let b equals to lambda and let c equals to omega. We want to derive an expression that we can use to solve. So this is going to be x squared plus lambda x plus omega equals 0. So this will give us x squared plus lambda x equal to this omega, we transpose it. So we have minus omega. So we complete the square here. This is going to give us x squared plus lambda x plus lambda upon 2 square minus omega. So somebody might want to know, why do we have this expression like this? I will explain to you in detail in my next video, where we will look at numbers to solve. So this is just like this. We are going to now have x squared plus this lambda x is not going to disappear totally. It is absorbed into this expression that I'm coming to write, which is lambda upon 2 squared equals to minus omega. So we add lambda upon 2 square on both sides. So we do it here again. Now we have square and square, so they are common. Just take one by saying x plus lambda upon 2 square everything equal to let's rewrite this, or we arrange it well. This lambda upon 2 square minus this omega. So if we introduce square root on both sides, this and this are going to cancel out. So we are going to have x plus lambda upon 2 equal to plus or minus the square roots of what? Lambda upon 2 square minus omega. So we are going to have x as what? This lambda upon 2, if you transpose it, it becomes minus lambda upon 2 plus or minus the square root of lambda upon 2 square minus omega. So this expression you are seeing, this is another formula we can use to solve quadratic equations. If you use this method, you are going to have the same answer that you obtain if you are using completing the square, graphical, or factorization.